lecture video and got the concept up till week 4. Hello. Am I audible, right?
Yes, sir.
Yes, sir.
Okay, so you guys have covered the lecture video of week 4. I mean, have got the concept till week
Yes.
4.
Yes, sir.
Yes, sir.
Okay, nice. But still, we will revise all the concepts, all the topics of week 1, week 2, and week 3 and week 4. So we will start week 1 and week 2. First, we will cover the concepts of week 1 and week 2. After that, we will take doubts of week 1 and week 2. After that, and we will cover the week 3 and week 4. Okay, that will be okay.
Okay, sir.
Okay, so
Okay,
let me share my screen. Okay, is my screen visible to all of you?
Yes, sir.
Yes, sir.
Okay, nice. So in week 1, we will start basically what is statistics, what are branches of statistics, what are types of data, categorical data, numerical data. We will cover the concepts of scale of measurements and all things. So, any one of you wants to tell us what is meaning of statistics? I mean, what is statistics? Anybody? Feel free to say.
Art of conclusion from data.
Okay. Anybody else?
Summarizing data.
Okay.
So analysis of data.
Okay.
Statistics is an art of learning from data.
Yes. Learning from data. Learning from data means you want to search some information from the data, right? So, and statistics is basically concerned with the what you can say, like collection of data. After collection of data, their description and their analysis, and after collection, after description, after analysis, what we can do the next step, we can do we can draw the conclusions, right? Okay, so major branches of statistics have 2 branches. First one is descriptive statistics, okay, and second one is inferential statistics, right? What is descriptive statistics? See, descriptive statistics is nothing but this statistic is concerned, you can say, it involves the description and summarization of data. See, description and summarization of the data means what? Anybody wants? Summarization of data means what?
Collective of data.
Yeah, summarization means you can do some numerical
Collection
or
of data,
graphical summary, right?
To get an overview, sir.
Yeah, numerical or some graphical summary, kind of, you can say. Like, you can also say summarization means to sum up the main points of something. Main points of something means you can calculate the mean of the data, you can find the mode of the data, you can find the median of the data, kind of thing, right? And see, descriptive statistics is nothing but the description and summarization of the data, right? So descriptive statistics can be done on sample as well as on population, right? And
Yep.
first, what is the sample? Let's talk about what is the population. Population is what? Population is nothing but the total collection of all the elements in which we are interested, right?
Yes, sir.
Right? Suppose we are interested in to finding the marks of a class, right? So what will be the population? Population will be the all the students of that particular class, right?
Yes.
Okay, understood. So population is nothing but the total collection of all elements in which you can say we are interested. We are interested in. So this is the something which is called population, like that example of the students of whole class, right? What is the sample? Sample is the nothing but it is the sub part of the population. It is the subset of the population, right? And one most important thing, sample should be a good representative of the population. What is the meaning of good representative? First, understood the sample. Sample is what? Suppose in that particular class there is a population of 40 students, right? So sample can be what? You can randomly select 10 students, right? So our 10 students will be the my sample, right? Is that okay?
Yes, sir.
Yes, sir.
Yeah. Now, you know, I said sample should be a good representative of the population. Good representative of the population means, suppose you want to find them, you are interested in finding the average marks of the students in some departments of a university, like some departments of, you can say, English departments, let's take maths department, okay, and you can say like history department, for example. So suppose these three are departments, okay. So all the students in these three departments will be your population, right?
Yes.
Right. Now suppose I want to the average marks of the for these three departments. So and I choose the random sample from maths department, okay, and I said the average marks or average scores of this, suppose this is the ABC university, of university ABC, average marks of the students in university ABC is 60. Then we this sample is best representative of the population or not? You got my question?
Yeah. Sir, this is not correct because it is
Right.
representing only one department, right?
Yes. So that's why this sample is not a good representative. Suppose I choose randomly students, some students from English department, some students from math, some students from history. Then I took the average of marks of those students. Then I said, yeah, average marks of the students in university ABC is 60. Then it will be the good representative of the population, right?
Yes.
Yes, sir.
Understood?
Yes, sir.
Yes.
Let's come back to the descriptive and inferential. You got the concept. What is the descriptive? Descriptive is what? Nothing but the summarization and description of the data. Data can be what? So descriptive statistics can be performed on sample as well as on population, right? Suppose I have a population of 40 students, right? Then I can find the average of marks of these 40 students. I can find the maximum marks of these 40 students, right? So I can summarize, as I can describe the population data also, right? As well as I can summarize and describe the sample data. Suppose I took the sample of 7 students, for example, then I can do the summarization, I can do the descriptive, I can describe and I can summarize the data of these 7 students, right? So thus your descriptive statistics can be performed on sample as well as on population. Till this point, it's okay.
Yes.
Now come to the inferential statistics. What is inferential? We focus on the word inference, means some information. So inferential statistics is nothing but the drawing conclusion from the sample data for population, right? Drawing conclusion from sample data for population, or you can say about population. So inferential means making
Sir, can you
inferential.
explain explain the descriptive? Good
Your
evening,
voice-
sir. Can you explain the descriptive?
Descriptive, right?
Yes, sir.
Yeah, see, descriptive is nothing but
Excuse me, sir.
descriptive. Yes, please.
This Jamboard is available for me. Available us.
Join
After the
board
class.
for
This Jamboard is available for us after the class.
okay, we will try to put on the portal. Okay.
Okay. Sir.
So descriptive statistics, what is descriptive? Descriptive statistics means you have to describe and summarize the data. Summarize the data means you are to sum up the main points of data. Some of the main points of data means, suppose you have data, you can find the mean, right? You can find the median, you can find the mode of etc mode of the data, right? So suppose let's take a example of 40 students of a class, right? So suppose I have a population of 40 students. So and I want to calculate the average marks. So can I calculate the marks average of the marks of the whole 40 students,
Yes.
right? So here what we are doing, we are just summarizing data, we are describing data. Yeah, average marks of the students is this, maximum marks of the students is this, minimum marks of the students is this. So kind of we are just giving some description, or we are summarizing the data, right? So in descriptive statistics, we are summarizing and describe the data. So we can have the population data, as well as we can have the sample data. So we can summarize as well as sample data or population data also. So descriptive statistics can be applied on sample as well as on population. Is this clear?
Yes,
Yes.
sir. Thank you.
Yes,
Now,
sir.
yeah, come to the
Wait,
inference.
sir, I have a question. I'm sorry.
Yes, please. Yeah.
Sir, I'm a little confused about the descriptive and inferential statistic. So, for instance, if my aim for the survey is to determine whether or not someone has the lowest marks in physics, so my ultimate aim for this survey is to determine that, right? So when I conduct a survey, I'm conducting an inferential survey, right? So I
See,
mean, you just mentioned that if I'm describing someone as the lowest or the highest part of the
no, see,
um,
it depends. See, what is the population of your data? Means where you want to do, you want to calculate the minimum marks of something. Like you wanted to do your survey on a particular college or class or whatever. There. Hello.
yes, sir.
Yeah. I'm asking where you want to do your survey. I mean, what is your population data?
My population data is, let's say, the college of
College, okay, and you want to do survey about the minimum marks, right?
yes.
Then you cannot do the, you cannot calculate the minimum marks through whole college, right?
No.
Then it's obvious you have to choose some sample, random sample means randomly pick the some marks of the some students, right?
Yes.
Okay, suppose in that college, let's take there are 1,000 students, right?
Okay.
So this is your population data.
Yes.
Right? Now,
Yeah.
you want to calculate the lowest marks of the students. Suppose you took the random sample of 200 students, right?
Yes.
Right. So this will be your sample. Sample
Yes.
means this is the subset of your population. Now you can calculate the lowest marks of these 200 students.
Yes.
Now, let's suppose lowest marks of the 200 students is, let's take 39, right?
Okay.
Now, you have this population data, you took a random sample and calculate the lowest marks of from this sample data. After doing this survey, you said you make the conclusion, right? The lowest marks in this college, let's say ABC college, in the ABC college, the lowest marks of the students is 39. Then here inferential statistics is used, because on the behalf of sample data, you are making the conclusion for whole population data. You are making inference, you are drawing some conclusion for the population data. This study is called the inferential statistics.
So basically, sir, any conclusions made on the basis of whole
Sample data.
population is a descriptive analysis, and anything made on the
No, can you repeat?
any conclusions made on the basis of conducting, I mean, sorry, let me rephrase that. Any conclusions made on the basis of studying the whole population is descriptive analysis, right?
No,
No, no.
not conclusion, not conclusion. When you are describing your data, right? Describing and summarizing the data. Summarizing and describing means, suppose you have students marks of, let's take population of 1,000 students, right? Okay, so suppose I'm interested in I want to some descriptive statistics. So descriptive statistics means you can calculate. See, it's little bit tedious task, but you can calculate. I can find the average of marks of students, right? I can do some summarization of the data. I can find the maximum marks of the students. I can find the minimum marks of the students of whole 1,000 students, right? Right or not?
Yes, sir.
Sir,
Yes,
is the possibility of finding the data is descriptive, sir.
So see, descriptive involves only the summarization and description of the data. That's it. See, descriptive. Suppose this is your population data. Suppose I have sample data of 200 students, right? Also, suppose I have only this data of 200 students. So I can summarize this data. Summarize the data. I mean, I can sum up the main points of the data, right? I can find the maximum of this data. I can find the minimum of this data. I can find the average of this data, right or not?
There is a possibility of finding data is known as
yes, whatever data you have, and you want to summarize that data only. You are not making any conclusion, any inferential, any prediction. No, nothing. You have to just summarize
describing the data.
Just describe the data. Just summarize the data. That called the descriptive statistics, right? And inferential, on the behalf of sample data, you make the conclusion for the population. That will involve the inferential statistics, right?
yes.
Yes, please.
So how can we determine from there that it is a good, this sample is a good representation of this population?
See, it depends on the question. Question is, suppose depends on the situation of question. Like, say this is the property of your sample. Say suppose I took the example of this one here. Okay, suppose you have a university ABC. In that university, there are 3 departments like English department, maths department, and history department, right? You want to calculate the average marks of the students, right? Of this college, this university, whatever you can say. Now, for this study, you select a data of some students, let's say 100 students from the maths department, right? And calculate the average marks of the students and say it come up to 60. And then you say like whole, average marks of the students in university ABC is 60. Then is this sample which you have selected from the maths department is good representative of the population or not?
Yes.
No. Why? Because we are selecting only from the maths. We are not considering these two, right?
Yes.
Yes.
So if you selected the random, you are selecting the random students from all 3 departments, and they take the average of the marks of the students and then said 60, then it will be the good representative. So it depends on the what is the scenario is given in the question. Okay.
Okay.
Is this clear for everybody? Descriptive and inferential.
Yes, sir. Yes,
Yeah, I'm still a little confused.
Yes,
I'm so sorry.
Sorry?
Hello?
Yes, please. Yeah.
Sir, can you explain IQR, sir?
Yeah, see, we are we will cover first week 1, week 2, and after that week 3 and week 4. So IQR will come in the week 3. Okay, no worry about that. We will cover all the topics of week 4. Okay.
Yes, sir.
Okay.
Sir, I have followed sir graded assignment 3, sir, also.
Okay, we will cover. See, first we will revise all the concepts of week 1 to week 4. After that, we will take the doubts of yours, right?
Okay, sir. Okay, sir.
Okay. So you got the concept in sample, population, descriptive, inferential.
Yes, sir.
Is that clear for everyone?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Now, so anybody wants to tell what is the inferential? On the behalf of sample data, when we make prediction for the
Make conclusion.
population, then see, suppose I have population of 40 students of a class, right? And I took a random sample of, let's say, 9 students from that class. Okay. And I calculate the average marks of the students, right? Let's say it's come up to 68. Then I said the average marks of this particular class is 68. Then it will be inferential or descriptive?
Inferential.
Sorry?
Inferential.
Inferential statistics. Because on the behalf of this sample data, right? On the behalf of this sample data, we are making conclusion for this population data, right?
Yes, sir.
Yes, sir.
Now,
Yes, sir.
come to, data has 2 types. You can say unstructured data, right? And structured data. Okay.
Yes.
Now, unstructured data is what? Unstructured data is means that is not, is this something that is not in a predefined manner, right? It's something, it's not organized in a predefined manner. Like you can say some feedback of students, right? So feedback, something, text messages, comments on YouTube. So this is something which are not already in standard format, or it is not in a
Raw
predefined
format
manner.
of data.
So this type of data is called the unstructured data, right? Unstructured data you can also interpret like from where it is little bit difficult to extract some information, right? Structured data is what? Structured data is something from where you can easily infer some information, right? Infer some information, or you can say it is clearly defined and searchable types of data. Searchable types of data means you can search, you can infer anything about the data, right? Structured data you can say easy to analyze, easy to search, and it's in predefined manner, like you can say sub tabular data, you can say, right? And unstructured data is it requires some more effort to work on the data, right? Like you can say unstructured data, suppose there is some data like you got the concept of comments and feedback, right?
Yes, sir.
This
Yes,
type
sir.
of data will comes under the unstructured data, right? Now, structured data is something like, suppose there is roll number, right? Student's name, and say you can say class. Okay. So suppose roll number is 1, student name is A, and the class is suppose 10. Okay. Or let's say mobile number. You can take class and mobile number. Mobile number is suppose 9935 something, and roll number is 2, student is B, class is 11, and mobile number is 8934 something, and class roll number 3, student C, class is 12, mobile number of suppose let's say 765 or something. So suppose this is something data, right, which is in already in predefined manner, okay, in tabular form. So from this from structured data you can, it's easy to search, it's easy to analyze. Easy to search means, suppose I'm asking like tell me the mobile number of the students B, then you can easily tell us the mobile number of student B, right? You can easily you can search in an easy way, right? Because it's already in predefined manner. It's in a tabular form, right?
Yes, sir.
Yes, sir. Yes, sir.
Okay. So
Yes.
this type of data comes under the structured data, right? It's
Sir,
safe.
can I give some more examples?
Yeah, yes, please. Go ahead.
Jesse number is unstructured or structured?
Which one?
Jesse number.
See, Jersey number, it depends on the data. Actually, Jersey number comes under the date. What I can say, categorical data and numerical data. It depends on the, you can't say like structure. Suppose it depends on the data. Suppose here is cricket, cricket player's name. Okay, this is their jersey number. Okay, and country, and then cricket player name like suppose MS Dhoni jersey number is 7, country is India. Then you can say bro jersey number is 17, country this. Then it's, you can't interpret for an individual, right? It depends on the what type of data you are given, right?
Yeah, okay, sir.
Okay, is that clear?
Yeah,
Yes.
clear, sir.
Okay, let's come to the variables and cases, right? Any one of you wants to tell what is cases and variables?
Case is the unit from which data are collected.
Yes, case is what? A unit from which your data is collected, right? You can say cases or observation. And variables is what? In layman term, we can say a characteristic that varies, right? Right? You name,
Sir.
yeah. You go to the words. If you focus on the word, variables is what? Is this something that varies, right? That varies about what? Across your all unit, right? So
Yes.
let's take example. Suppose I have an example of, and one more important thing, your cases should be unique, right? Unique means, let me take example. Student name, suppose their class, okay, and suppose their let's take region, okay, or you can say state, okay. Suppose student name is Rahul, class is 10, state is just a Delhi, okay. Rohit, let's take class 12 and the state is from, let's take Haryana, okay. And suppose there is a Suman, class 12, okay. Suppose this is from UP, and suppose Sumit, suppose this is also from, and suppose BR, okay. So suppose this is data you are given, right? So can you tell me, see, forget about the roll number till now. So can you tell me what is the case?
Student name.
Student name.
Student name.
Student name is case, or Rahul is a case?
Rahul is a case.
Rahul is a case.
Rohit.
And what about student name?
Variable.
Variable.
It's variable because see, it's vary, right? It's varying if you see, right? Now, what is the class?
Class is variable.
Class is also variable, right? What is region, or you can say state? State is also
Variable.
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 Now, why Rahul is a case? Because this is something, this is a unit from which your data is collected, right? Rahul is a unit, you can say. And one more important thing, row represent your cases and variable column represents your variables, right? So Rahul is what?
Sir, can you
is
repeat that once again?
I said row represents the cases and columns represents the variables, right? Rahul is a case because for Rahul we have collected data. I mean, he's from his 10th class, he's from Delhi. Rohit is also a case, he's in 12th class, he's from Haryana. Suman is also a case, he is in class 12th, she She is in class 12th and she is from UP. And Sumita ji also case she is from she is in class 12th and she is from he is from Bihar. Now, so I said one important thing: cases must be unique. Unique means suppose instead of one Rohit, there is two Rohit. Okay, and he is in class 10 and he is from say again Bihar. So will sorry. So is Rahul will be a case or not?
No, sir.
Why?
Yes, sir.
No, sir.
Why?
It may repeat, right, sir?
It may repeat. And in this particular table, it is repeating. It is repeating means Rahul is not repeating, but Rohit is repeating, right? Rohit is two times, but it's not unique, right? So cases must be unique. Suppose there is a column of roll number. Suppose roll number is 0, 1, 0, 2, 3, 4, and 5. So roll number is unique, right? So here your roll number will be your case.
Yeah.
Right?
Same roll number.
Because suppose I'm asking, tell me state of the Rohit. Then you might get confused which Rohit I am talking about, either roll number 2 or roll number 5, right? So this is something where things are repeating, but here roll number is unique, right? So here roll number is the case, and suppose I'm asking, I said, tell me the state of the roll number 2. Then you can easily tell me the unique values, right? So here roll number 2 is the case. For C, this is also row. So for this row, and your row represent the cases. Similarly, your here row represents the cases. So your 4 is the case. Your 0, 1 is the case. So is that clear for everyone?
Sir,
Yes.
just one query, sir.
Yes, please.
Let's say in a data, we don't have the roll numbers. We have just the student names and then the other variables that we have.
Okay. Then
over there also, the name can be repeated like we did it for Rohit. Will it still continue to be a case in that situation?
No. See, there must be a
constant.
column. There must be a column which represents your case, right?
Yeah.
There should be a column.
So if there is not available, I'm just asking a probability.
No,
I know for the exam probably it will not be there.
No, listen to me. If in your exam question is about your case and variables, so your case, there will be a column which represents the unique values.
Okay.
It will be there. Don't worry about that. If he's asking about that from this table, will be the case, then there will be the unique values.
Yes, sir. So from exam perspective, I've understood. I'm asking from a further concept perspective. If there is a data wherein we don't have the variable, meaning the name is repeating and I don't have a serial number equivalent or something which is unique for irrespective of what the case is, then at that point of time, what do we do?
Then I think first of all, there should be something which should be unique.
So there has to be something unique.
Yes,
if not, we create.
Yes.
Right?
Because see, if names are repeating, then you can't say like these are cases.
Yes. That was my query.
So there should be something, right?
Okay.
Sir,
okay.
Sir, in a tabular form data, will there be a single case or multiple cases?
Excuse me.
No, it can be multiple cases, right? Suppose in this, here are 5 cases, 1, 2, 3, 4, 5, right?
I'm talking about the variable from which the cases are coming. Will there be a single variable which the cases are coming or multiple?
Sir, excuse me.
I did not get your question actually. Can you repeat?
Sir, here from roll number only all the cases are coming now, sir. Will there be a situation where there will be 2 variables from which the case?
2 variables from?
From which the cases can be written.
Not getting the question. Anybody?
Sir, excuse me.
I think there can.
He is asking that as the roll number is a case and Rohit is also.
No. See, roll number is not. If I'm talking about roll number is a variable. 0, 1 is a case.
He's asking that the unique variables like roll number. Can there be multiple variables like that?
Okay, like
He
there is something.
sir,
Suppose
he's
Sir, sir.
basically
let's
as
take
the
this.
role number 2 is there.
Yeah.
As the role number 2 is a case, and Rohit is also a case, then will we counting that as a 2 case or a single case? I think.
No.
That
Then
was
you have to consider roll number, right? Suppose
Yes, sir, that was
this
my
Rohit,
query.
yeah, this Rohit is not there, right? This column is unique and this column is unique. Then you have to consider this one, because for this case, see, case is, if you have to focus this is a unit from which your data is collected. So for roll number 1, your all data is collected. For roll number 2, your all data is collected. For roll number 3, your all data is collected, right?
So, for example, if we
Yes, sir.
have two Rohits, like on roll number 2 and on roll number 5, then will we consider it a case?
No, consider case as a roll number, because cases should be unique, right?
Sir, your voice is not clear.
Okay.
Yes, sir. Your voice is not clear.
Is that
Could you please repeat that?
is that for everyone, or now am I audible?
Yes, sir.
No,
Sir,
sir, your
please
voice
repeat.
is not audible.
Hello.
So you're audible, but sometimes it's gets jargons in your voice. So
Okay.
So please repeat that.
Voice is not clear,
Now
sir.
is that okay? Hello. Now is this okay?
yes,
Sir,
no,
yes,
finding
please.
it okay, but
Now fine.
when it will be happen, we'll let you know.
Okay, I think there might be some network.
Yes, sir. So
Okay,
please repeat that.
Yeah, I'm saying, see, roll number and student name. Okay, so roll number, see, cases is something which should be the unique, right? Here Rohit is repeating, right? Means
sir.
your names are repeating. That means your cases should be unique. So here roll number cannot be repeated. Means, see, same roll number cannot be for two different people, right?
Yes, sir.
So here 01, roll number 02, roll number 03, roll number 04, roll number 05 is a case. Suppose I'm asked, tell me the state of the students of roll number 2. Then you can easily tell me the, Haryana, right?
All right, sir. Sir, it
So-
means that students' name are not the case here. I mean, Rohit.
Yeah, here not a case. Suppose
Okay.
there is not a column of roll number, right?
Yes, sir.
Suppose a column of roll number is not there. For example, it is not there, right? Then student name are there and Rohit is not repeated. Then all the students are unique here.
Yes.
For this particular, let's create a particular scenario. For this particular scenario, your names are your cases, right? That means you have to be focused. Row represents the cases and cases should be the unique. That's it.
All right.
Sir,
Thank
let's strike out the second row itself and
Yes.
have the roll numbers. Will there be for which we should consider case, sir? Both are unique.
Sorry.
Sir, we strike out Rohit, sir. We have the roll number column.
Then roll number, you have to consider roll number.
Why, sir? Both are unique.
No, see, both are unique, but see what? For your row represents is what? Your row is this whole things, okay? And one more important thing, row cases is what? Is this a unit from which your data is collected, right? Suppose roll number is there. Roll number, see, you have to see one more thing for best practice. So roll number is something best which will be the unique, right? And for roll number 1, you have collected the data of student's name, you have collected the class of the student, and you have collected the state of the student, right? So roll number will be the cases, right? Is that okay?
Yes.
Yes, sir.
Okay. Now let's come to the data. I mean, types of two data, which will cover, which will consist of categorical and numerical data, right? Now,
So
see,
one question, sir.
Yes, please.
So in that question only, Delhi, Bihar, UP, Haryana are different. So would that be a case? All different.
See, what is the definition? Please be focused on the definition. Definition what? A unit from which where data collected. You are not collecting the data from Delhi. You are collecting the data on the behalf of roll number or of student name, right? For roll number 1, you have collected the data for, I mean, student name and your data of their class and your data of their state, right? And here, if you see,
Okay, sir.
Bihar is repeating. Okay.
Yes, sir.
Is that clear?
Yes, sir.
Okay. Let's take
Excuse me, sir.
categorical
So
and
Bihar is
numerical value.
2 times repeat, so it's not variable, sir.
It's not a case. And first, see what I said, row represents cases, right? First thing. Second thing, case is a unit once your data is collected. See, here you are collecting the data from UP or on the behalf of roll number.
So voice is breaking, sir.
Okay. Now see, I said here data is your data is collected from on the behalf of state or on the behalf of class or on the behalf of roll number.
Roll number, sir. Yes, sir.
Just don't consider these 5 rows only. Like think if you
Hello?
have lakhs of data and if any column or any particular field which is unique till the last, you can consider this as an observation. Just don't go with these 5 fields. If you have, like example, we have a email ID is unique and your mobile number is unique.
Yes,
So
unique.
consider that field, and for that field we are collecting a different observations. So this is a case, and the variable is mobile number. The column name mobile number is a variable, and particular mobile number is a case.
Yes. Okay. Is that clear now?
Yes, sir.
Okay. Let's move for the types of data. I mean, categorical data and numerical data. See, categorical data is what? It's something which are qualitative in nature. Qualitative in nature, and numerical data is something which is quantitative in nature. See, qualitative in nature means what? You can identify some group membership, right? Some group membership means what? Suppose you have a data like you can say gender. So you can make some group like female, male, right? Okay. And see, and in numerical data is something where quantity is there. Quantity is there means, and you can perform some meaningful mathematical operation, right? You can say like numerical variable, you can take anything, speed of a vehicle, age of a person, weight of a person, anything, right? So suppose you have a like marks of the student, right? 84, 96, 72, 65. So this is something, this is the data on which we can perform some meaningful mathematical operation. Meaningful mathematical operation is we can perform addition, we can perform subtraction, we can perform multiplication and division. And categorical data is something on which we cannot perform any meaningful mathematical operation, right? These are qualitative in nature.
Excuse me, sir.
Suppose, can you perform female and male, any mathematical operation, female and male? No.
Yes, sir.
Only qualitative.
Example of jersey number. Okay.
Yes.
Okay. So let's take a example of jersey number. So can we perform any meaningful mathematical operation on jersey number?
No, sir.
Yes, sir.
How can we perform mathematical operation? You cannot perform. Suppose jersey number is some player is 7, some player is 10, and some player is 11. So you can't say like 10 jersey number 10 is greater than jersey number 7, right? It's just a label.
Yes.
Right? It's just a label thing. You can I mean, there is not a meaningful kind of thing like 10 plus 7 equal to.
Yes, we cannot perform arithmetic operations.
Yeah, you cannot perform any meaningful mathematical operation. Okay, categorical data is just a kind of label. We are not able to perform any meaningful mathematical operation. Let's take example of pin code, right? Pin code is a categorical or numerical?
Categorical.
It's
Categorical.
Let's what is this?
Mobile number is
Numerical.
categorical.
Categorical or numerical? Categorical. Because see, this is kind of just a label. You can't say like your mobile number is greater than my mobile number, or sum of
Sir, we can't hear you.
The screen is stuck.
I mean, there is not a meaningful mathematical things, right? Aadhaar card number. Hello.
Categorical.
You got the concept.
Yes,
Sir, please repeat categorical
Yes,
data,
sir.
sir.
So can you repeat again what you said before?
Sir, can you repeat, sir, categorical data?
I think this is a weak, discrete and continuous is weak one, right?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Okay.
Can't hear you, sir.
Sir, is Aadhaar card numerical or categorical?
Categorical.
We are unable
Tell
to
me the
hear
discrete
you.
and continuous. I mean, it can take distinct value on real number line. Distinct value. Okay. Now, continuous is something which
Sir, we can't hear you.
Continuous is for measuring.
Sir, your voice is not
it is
audible.
there. For example, for discrete.
Sir, I couldn't hear you the previous
Sir,
time,
can
sir.
you hear us?
Yeah.
So sometimes we are unable to hear you, sir.
Yes,
We
sir.
are missing the part.
Totally, means your voice is not audible, sir. So can you please check with your internet connection and all? Yeah.
Now am I audible?
Yes, sir.
Now we are audible.
Hello.
Yes, sir.
On the
Is my
Sir, your voice is breaking.
Now it's breaking.
Still breaking, sir. It seems like you're having network issue actually. We lost you in between.
one second. Let me something. Hello.
Yes, sir.
Yes,
Am I audible?
Yes, sir.
It's clear.
Yes, sir.
It's clear for everyone.
Yes, sir.
Okay. Is my screen visible, right?
Yeah, visible, sir.
Yes, sir.
Okay. Now see, discrete is something where you can count. Just take, I'm saying number of people in a house, right? So I can count the number of people, right? And if you see on real number line, you can plot like distinct, like, yeah, 1 people, 2 people, 3 people, 4 people, right? So something which you can count, right? This type of things comes under the discrete data. Let's take number of languages a person can speak. Will it be discrete or continuous?
Discrete.
Will be discrete.
Discrete. Okay, you got the discrete. Let's come to the continuous. Continuous something where measurement is involved. Means you cannot count the data, but you can measure the data. Measure the data like I can say height of a person, right? So height of a person you cannot count. You can measure. You can measure in centimeter. You can measure in meter. You can measure in feet, etc. Right? Let's take weight of a person. So you can measure weight of a person in kilogram, but you cannot count. And continuous something, it can take any values between an interval, right?
Yes,
Is that clear?
Yes, sir.
Let's take,
Yes,
tell me speed of a vehicle will be what?
Discrete.
Discrete.
Continuous.
Continuous.
Why
Continuous.
why discrete and why continuous?
The
Sir,
speed
it
will
can
have
only be
decimal
measured.
value in it.
Continuous because it has.
We are measuring the
Yes, speed you cannot count. Speed you can measure in kilogram,
only
sorry,
measure
kilometer per hour, right? And don't go with the like decimal value, then it's continuous. See, I said suppose I have 1 rupees, 1.5 rupees, 2 rupees, and 2.5 rupees, right? And 3 rupees. Then will it be discrete or continuous?
Continuous.
Discrete, sir.
Discrete, sir. Discrete.
Discrete, because I can count.
Discrete.
I can count. I have 1 rupees, 1.5 rupees, 2 rupees, 2.5 rupees, 3 rupees, and if you, it can take a distinct value on the real number line. Okay.
Sir,
Continuous
one more
something.
question.
Yes.
One more question.
Yes. Yes.
मतलब एक और क्वेश्चन दीजिए चेक करने के.
Okay, you are saying like one more question, right? See, price in something, you can say stock price or something share market, that is something which goes in the some continuous. But here suppose I have 1 rupees, 1.5 rupees, 2 rupees, 2.5 rupees, 3 rupees. So see this in particular scenario, I can count these rupees, right?
Yes.
I can count or not?
Yes, sir, you can.
And it can take distinct things, right? It's not taking any value between an interval. So
Sir,
this particular example is for the discrete.
is age of a person is discrete or continuous?
Age of a person is okay. Tell me what it will be.
Discrete.
Continuous.
That's
Continuous.
Discrete.
Sir,
Yes. Because see
sir,
why
if
discrete?
height of 5 people is given, will it be discrete or continuous?
See height of a
Continuous.
person, whether it is 5 people, 6 people, doesn't not matter. Is if it's height, then it will be continuous, because height is something which you are measuring. You are not counting.
in feet
Right?
or inches.
Okay, you are see, so height of what is height? Height you can measure, right?
Yes, sir.
Yes, sir, it has units.
Yes, weight you can measure.
But then what about age?
Discrete.
Okay, so is that clear for everyone? So we can move for
So
the
one
next.
question.
Yes.
Sir, then battery life will be continuous, right? Continuous
Battery life will be
variable.
continuous because yeah, it will be continuous. Okay.
So yes,
Any unit have a measurement, then it is continuous.
Sir, I
Yes,
have
yes, yes, yes. Yeah.
So what about age, sir? Can we measure it or count it?
Okay. No, see, will a height of see Nitesh, it's not about 5 people, it's not about 6 people. If it's height, then
Age,
it will be
sir.
continuous.
Age.
Then how about
Because
age?
okay, tell me
Age.
what about age?
It is age,
Is
discrete
age
or
of a
continuous.
people is continuous or discrete?
It's suppose age age is given in years, right? Then
Yes,
it
sir.
will be continuous. Right or not?
Yes, sir.
Yes, sir.
yes,
Yes, sir.
Right? Because age is something what? You are measuring in
Measuring the
years.
Yes,
And
sir.
something you can say like 22 years, 11 day, 9 minute and something. Suppose age of a person.
yes, sir.
Yes, sir.
So it can take any value between an interval, right?
Okay.
Sir,
Yes.
Yeah.
sir, I read it's one definition of discrete data that it contains whole numbers or integers, which means that the data cannot be split into fractions or decimals.
Okay, where is this?
And sir, in previous slide, you gave us an example in which you split the data. The data was in
See,
1 and
it's
1.5.
no. It's about you can count or not, right? Suppose you see 1.5 rupees is what? 1 rupees and 50 paise something, right?
Yes, yes, sir.
See, just think about it. If you can count, then it will be discrete. If you can measure, then it will be continuous. That's it.
As you just said
Okay.
that age in years will be continuous. So, but we
Yes.
are measuring. So, similarly, we are counting the currency in the terms of rupees, right? So, cannot it
Okay.
be continuous as well?
Okay. Just think about it. Why? See, age is something what? Age can be like, suppose I'm asking, tell me the age of mine. So it might be like, suppose it can be like 20 years, 11 days, 9 week, 2 minutes and something, or something seconds. Are you getting my point?
Yes, sir.
Yes, sir.
So this is something which you can measure, right? And this is something it's take in continuous value, right?
Yes, sir.
See, I took the example of this one. Just think about that. You can count or not. If you are facing difficulty in that, Then we can discuss and at the end of the session. Okay.
Sir, excuse me, sir.
Okay, sir. Okay. Yeah.
Sir, I have an doubt, sir. Sir, if I get 80 marks in physics, then physics is called a categorical data or not?
See, if you are talking about subjects, then it will be categorical. If you are talking about marks, then it will be numerical.
Okay, sir.
Okay. Okay. Till this point is clear. So we can move further points because we have to cover a lot of topics as
Yes,
well.
sir.
Yes, sir. Yes, sir. Please.
Okay. Yeah. Yes, please.
Yes, sir.
Sir, is sir.
Sorry.
Sir, can you hear me?
Yeah. Yeah.
Sir, continuous data only measures certain quantity, no, sir. It does not count.
Yeah, it does not count. If it's count, then it will be discrete. That's it. Let's say, suppose I'm saying number of people in a household, then you can count, right?
Yes,
number of like say number of language is spoken by a person. You can count one language, 2 language, 3 language. But I'm saying speed of vehicle. Then speed of vehicle. See, suppose speed of vehicle you can count or you have to measure. You have to measure. Weight of a person you can count or you have to measure.
Measure, sir. Measure.
That's it. That's it about discrete and continuous. Okay.
Thank you, sir.
Okay. Let's
Yes,
come.
sir.
To, let's move for the cross-sectional time series data. Okay. Time series data is something what? The data in which time vary, right?
Yes,
Okay.
sir.
Means your data recorded.
Yes, sir.
Your data is recorded over time, and cross-sectional data is recorded at the same time. Okay. For example, let's take, suppose I'm interested in measuring the temperature of Delhi. Okay, on Sunday, right? Then Monday and Tuesday, right? So let's take Sunday, Monday and Tuesday. Okay, suppose at the Sunday there is X degree Celsius temperature, Monday Y degree Celsius temperature, Tuesday is Z degree Celsius. So here your time is vary, right? Time is vary means what? Sunday, Monday and Tuesday, right? So this type of data is comes under the time series data. Okay.
Okay, sir.
Okay. And cross-sectional data means something in which your data is collected at the same time. Same time is, suppose I collected the data of Delhi state, let's take Chennai, okay, and Haryana on a particular day, that is Sunday, right? So here your time is same. At the same time, at the same day, we have recorded the temperature of the different places. So this type of data comes under the cross-sectional data. Means time is same, but places are different. Here place is same, but times are vary. Means time is vary. Means over time. Is that okay?
Yes, sir.
Yes.
Yes, sir.
Okay. Let's move for the scales
one
of
second, sir.
measurement. Yeah.
Can you
The
ask
time plot means
Sorry.
time plot means
Which plot means? Say time plot is
sir.
what? Time plot is something just a graph of time series. Okay.
Okay, okay, sir.
Okay. Okay. Scales of measurement. See, scale of measurement. See, we have 4 scale of measurement, right? Nominal, ordinal,
Interval,
and
ratio.
And okay. Now, see, let's cover the nominal and ordinal. See, nominal and ordinal scale of measurement is basically for your categorical data, right? And interval and ratio is mainly for the numerical data. Okay. Now, see, there is some background noise. I don't know from there. Yeah, please mute yourself. Okay, then I mean you heard out, so you can unmute and ask. Okay, so numerical, nominal, ordinal covers the categorical data, and in interval ratio is applied for the numerical data. See, nominal scale of measurement is nothing but it's something in which when our data consists only labels or name, right? Not labels or name, right? You can say name of person, right? For gender, right? You can say blood group.
Can you repeat?
Number.
See, I said nominal data. In nominal data, we have to do labels or names. Okay. So some data which sorry. Yeah, please mute yourself. We do not have any doubt. Yeah, see, in nominal data, see, when our data for a variable consists of only labels or names, it will comes under the nominal data. Now, see, labels or name means what? You can say, suppose, for example, name of students, right? So name of students is something, name of a person is something what? It's just a label, right? Rohan, you can say is a label, Rohit is a label. Gender, what can be? Female, male. So this is just a label, okay? Blood group.
So first, can you mute centrally? Sorry to interrupt, sir. Can you mute centrally? Yeah.
Yeah. Now, is that okay? Yeah.
Yes. Sir, in scale measurement, sir, the third number is what? Nominal, ordinal, and
interval.
Interval.
Have not covered the lecture video yet.
Yes, I have covered, but
So I have a doubt. Can number be a nominal?
Which number?
Yes.
Generally, can number be a nominal?
See,
Jersey number.
See, it's depends.
Their age will be a nominal, right? I think whatever 20, 25, 30, whatever.
Why age will be nominal?
I'm just asking as a query because this is more of a
no. AC
It's ordinal.
Okay.
See what?
Yeah,
Tell me
correct.
what? Yeah, first listen to me carefully. I said categorical numerical is what? Categorical is something where you cannot perform any meaningful mathematical operation. Numerical, where you can perform meaningful mathematical operation. Now comes to the nominal and ordinal. Nominal and ordinal scale is for categorical data, and interval and ratio is for numerical data. Now, we start from a new page. See, nominal scale of measurement is what? When your data for a variable consists of labels or names, okay? That type of data will comes under the nominal scale of measurement. For example, you can say, suppose I'm saying gender, okay? Gender can be female or male, right? So these are just a label. These are a nominal. You cannot order female greater than male or male equal to female or female greater than male, male is less than something what? You cannot order. Means just a label thing, right? Blood group what? This is just a label. A positive, A negative, B positive. These are just a label, right? Now, come. Let's take example of jersey number, right? Jersey number is also nominal data. 7 jersey number, 10 jersey number, 17 jersey number, 6 jersey number, right? So jersey number is nominal data because you cannot say like jersey player of jersey number 10 is greater than the 7, right? Or 17
Yes,
jersey number is greater than the jersey number 6. So this is now some meaningful mathematical something comparison. These are just a label. This is a player. For this player, jersey number is this. That's it. Okay.
What about a mobile number, sir?
Mobile number is also nominal.
The order of the number does not have any meaning.
No. See, what is the meaning? So is there any meaning? You can say your mobile number is better than or greater than my mobile number. Is that this is making any sense?
It's simply like mobile number for you. It is just a label.
And just a label. See, mobile number is just a label. Pin code is just a label. Pin code is label for the area, right? Aadhaar card number is just a label.
We cannot perform any meaningful operation on it.
Yes. Means, see, nominal, you can say these are just name categories, okay? Name categories without implying any order. That's it. Means it's just a name category, just a labeling without any order. That's it. Yeah, right?
Sir, can you please tell what scale of measurement will be of mobile number?
I said mobile number will be under the nominal scale of measurement. Okay.
Okay, sir.
Okay, and one more, you can say request or something. See, let's cover the first topics of the week 1 and week 2. After that, we will cover, because it's 1 hour almost here complete, and we have to cover all. I mean, remaining 3 weeks as well. Okay. So, I mean, you can ask your doubt, but don't make yours. Okay, is that okay?
Yes,
Okay,
sir.
because we have to cover all the topics. Otherwise, it will be too late. Okay. You have doubt, then you can raise hand. We will discuss. Let me first finish the topics. Then we will discuss doubts, and after that finish topic. Okay. Now comes to the ordinal. See, now you got the nominal scale of measurement. It's just a name category. It's just a label without any order. Mobile number comes under the nominal. Pin code number is just comes under the nominal. Okay. You can say Aadhaar number is also comes under nominal. Jersey number comes under the nominal scale of measurement. Okay. Ordinal, come to the ordinal. Ordinal is nothing but is same as the nominal, but here order will be applied. Okay. Means order, or you can say rank of data is meaningful or is there, you can see. Right now, for example, you can say can I say like feedback of the you can say service rating of a restaurant, right? I can say like excellent, okay, good, okay, poor. So see, this is the label. This is for the categorical data, right? But I can order like, right, excellent, good, poor. I can order or not?
Yes.
So this type of data will come under the ordinal scale of measurement. Okay, suppose something you can say like this sizes of the sorts, right? Small, medium, large, extra large. So this is the ordinal data as well. Okay, because small is just a label, medium is just a label, large is just a label, XL is just a label. But I can order the small, then medium, then large, then XL, or XL, then large, then medium, then small. Okay. So this type of data will come
Okay,
under the
yes.
ordinal scale of measurement, because it's something name categories, okay, that can be ordered. Okay, this is something. Now, is that clear? Nominal and ordinal for everyone?
Yes, sir.
Yes, sir.
Okay, let's come to the interval scale of measurement.
So one doubt.
Yes, please.
Sir, then how can soccer position be not an ordinal scale measurement?
Soccer position of the previous qualifier paper.
Yes, sir.
So see, you know about soccer positions, midfielder and all.
Yes, sir.
Then see, they are not, they are just a labeling, right? Interval and ratio scale of measurement is basically, yes, please.
Sir, I have one small doubt. Sir, is blood group nominal or ordinal?
Yeah, it comes under the nominal. Because see, nominal is something where you can just give a label but cannot order. In ordinal, you can label as well as you can order, right?
Okay, sir.
Now come to the ratio in the
Sir.
yeah.
So what will be the scale of measurement for model number? So suppose HP laptop,
Nominal.
why, sir? Because that model number may be in order, may have some particular order. So for example, HP Pavilion 1 and HP Pavilion 2.
Then it depends, HP Pavilion 1, HP Pavilion 2. Like it's, we are talking about 11 generation, 10 generation kind of. It depends on the data actually. Okay. But see, if you're talking about like HP, Lenovo, Dell, and Asus, and whatever, then it's just a label and just a,
yeah, it's nominal. But if I'm talking about particular series, Pavilion series or something, then
it will be order. See, if it's labeling and you can order, it will be ordinal. That's it.
Okay.
Okay. Now come to the interval and ratio. It's 1 hour 15. Yeah, interval and ratio scale of measurement. See, interval scale measure in interval scale of measurement, interval between the values has a fixed, means it's a something constant type. Okay, and for the interval data, you can perform addition and subtraction. As well as in interval scale of measurement, there is a basic property, very important property, which is no absolute zero. Okay, see, in interval you cannot perform like multiplication or division. You can perform addition, subtraction, means
Can we
no,
only add subtraction?
yeah, no ratio comparison, no ratio comparison. And there will be, and one important property, no absolute zero. You know, you know the meaning of absolute zero, right?
Can you explain
Absolute
it?
zero means
Yes, sir.
absence of something, absence of that particular thing, right? So absolute zero means absence of the particular thing. See, right? Suppose I'm saying, yeah, interval scale mean, let's take an example of temperature, right? Degrees Celsius. So no absolute zero. Suppose I'm saying 0 degrees Celsius. So is there absence of temperature?
No, sir.
No.
No,
If I'm
sir.
saying, yeah, if I'm
No.
saying 0 degrees Celsius, then still there is some
Go
temperature,
to
right?
no
Right?
low degree. Yeah.
And it can go in negative also, -2 degrees Celsius, -3 degrees Celsius, right? There still will be some temperature.
Yeah.
So
Yes, sir. Yes.
no absolute zero means absence of something. Suppose I'm saying 0 number of pen, that means there is no pen. 0 number of books, that means there is no books. But suppose I'm saying 0 degrees Celsius, that does not mean there is no temperature. There is some temperature. It can go in negative as well. Okay.
Yes,
Now,
sir.
same for the applicable for the Fahrenheit and
Hello?
in
Sir,
interval scale of measurement,
excuse me, sir.
ratio. Yeah, yes, be.
Sir, if in the case of marks, someone got 0 marks, it in ratio or
Yeah, I will come to that. See, if there is absolute zero property, right, and you can make some ratio comparison. Like suppose I'm saying, I think in interval degree there is -273, right, minimum, if I'm not wrong. Okay, suppose from here this is 20 degrees Celsius temperature, this is 40 degrees Celsius temperature. Okay, so can you say the distance from this is, and distance from this to this distance B, and suppose this is the A, is B 2 times of A?
No, sir.
You cannot say, right? That means here ratio doesn't not make any sense, right?
Yes.
Okay, you got why I'm saying in interval only addition or subtraction is performed. And if it's interval no absolute zero, means it can take value below the zero also. Suppose this is a 0 degree Celsius, then it can take a value between the, below the 0 degree Celsius. That type of interval scalar measurement comes to the, so that type of data will come under the interval data. Now cover the ratio of scalar measurement. In ratio of scalar measurement, we can perform addition, subtraction, multiplication, and division as well, right? Now, and here absolute zero is there. Absolute zero is there means there is meaning of zero. Suppose I'm saying, yeah, let's take the example of marks. Okay, suppose minimum marks is 0, right? Minimum marks can go 0 for a particular scenario, and a student A get the 20 marks and another student got the 40 marks, right? So can I say B got the 2 times marks of the A?
yes?
Why I can say? Because there is absolute zero. It's not goes beyond the 0, right?
Yeah.
So here ratio makes sense.
Yes, sir.
Right? Here meaning of absolute zero, right? I'm saying 0 marks. That means he does not he does not have any marks, right?
It doesn't.
Yeah.
Below
Yeah. Yes. And suppose that of example of negative marking, then will it be interval or ratio? Hello.
Ratio.
Interval.
Negative marking will be interval, ratio.
Interval.
Interval. Why interval?
Because no absolute zero.
Because it is going zero, which
Yes,
is
it is going below the zero as
zero.
well, right?
Yes.
Now, hope you got the concept. Now, let's.
Excuse me, sir.
Yeah.
That in this session, all covered 4 weeks of session.
Yeah, we have to cover all the 4 weeks.
Okay.
It's a little bit late, but we have to cover actually. Okay, let's come to the you. I mean, you got the concept of week 1, right?
Yes.
Okay, come to the week 2. In week 2, we know the frequency. I mean, we have to cover the frequency distribution, relative frequency, and all things, right? You know what is the relative frequency?
Total
So frequency of a unit in relation to the total frequency, sir.
Yeah, total frequency, or you can say total number of the observation. See, total number of observation is what? Sum of all the frequency is equal to the total number of observation. Okay.
Yes.
Is that clear? Relative frequency for observation, I'm writing I in subscript, is equal to frequency of that observation divided by total number of the observation, right? Suppose you are given like group A, group B, group C, something you can say game A, game B, game C, and player number is for game A is 10, player number for game is 20, player for the game C is 30. Then how many player is there total? 60, right? I suppose I'm asking the what is the relative frequency for player for game B?
The 20 upon 60.
20 upon for game A, 10 upon for game C, 30 upon 60. You know, sum of all the relative frequencies should be
1.
Okay. Now, is that clear? What is the relative frequency?
Yes, sir.
Let's come to the charts. Charts. In charts, we have to cover pie chart, okay, bar charts, and Pareto charts, right?
Histogram.
Histogram is in week 3. Okay, histogram is something for continuation. Okay. Now, pie chart is what? Pie chart is nothing but it's just you can say it looks like a circle which are already divided into pieces, right? Pieces you can say which proportional to the some percentage, proportional to the relative frequency of the share is the good word. You can say, see, pie chart is what? When we want to show the share of a particular category, right? Share of a particular category. Okay. Now, bar chart is what? In bar chart, we have to use when we are interested in showing the count of something. Okay. Okay. Count of the category. Right. Now, Pareto chart is what? When you have sorted the frequency, right?
Some order.
In order. So these are the basic difference between these charts. Okay. Pie chart, when we want to say show the share of some particular category. Bar chart, when we are interested to show the count of category. And Pareto chart, when we already sorted the frequency in order, right? Now let's take an example. Example of something is what? Let's take an example of suppose I'm interested in so to displaying the breakdown of sales for items which are produced by a company, right? So I'm interested to want to show what share of items of a particular share of items of a company for a particular year. Okay, suppose let's for year 22, I want to show what are sales of the each items. Let's take items for that that company are 4 items A, B, C, and D, right? And for A it's A%, and for B it's B%, and for C it's C%, and for D it's D%. So these are the share of the items which are sold, or what you can say, throughout the year, right? So here we are interested in showing the share of the items, right? So we can show by the pie chart, right? And you know, all the percentage should be equal to what? 100%.
100%. 100.
So that is the something which we cover in the pie chart. Is that clear? When you are showing the some
Yes, sir.
percentage, when you are want to show the some share. Now come to the bar chart. Bar chart is something. Let's take example. Suppose in a school there is some in every school or college, you can say there is election. So in that election, okay, suppose this is, I'm interested to know the count of votes. Let's say there are 4 students, X, Y, okay, Z, and let's say A. They are the 4 students. Okay, so 4 students, and I'm interested in how many votes they are get. Suppose X got the 10 votes, and Y got the 15 votes, Z got the 5 votes, and A got the 20 votes. Then in such cases, bar chart is the most appropriate, because we are interested in the counting, and we can easily say that what is the maximum number of votes, or which student got the minimum number of students, student got the maximum number of students. Okay, so here we are interested in count of the votes. So for this scenario, bar charts will be more appropriate. Is that clear?
Yes, sir.
Yes, sir.
Now,
No, sir.
okay, what is your doubt? Hello.
Tell fast.
So move forward.
Move on.
Yeah. Okay. So what is Pareto? Pareto chart is something when we have to sort the frequency, right? Like suppose I have sorted A, right? And then 15, then 10, and then 5. Okay. Then this is A, this is Y, this is X, this is Z. So here this type of chart. It's called the Pareto chart. Is this clear?
Yes, sir.
Now
There is this ordered bar chart.
Ordered bar chart. And one more important thing, if your data is ordinal data, right? If your data is ordinal data, yes, please.
Yeah, Roshan.
Yeah.
So can we make it ascending order also, Pareto chart?
Yeah, you can make it.
Okay.
But remember, order should be preserved. No, I mean frequency should be ordered. And for ordinal
It's also
data,
decreasing, sir. Decreasing
Yeah.
order will be possible.
yeah, you can plot in both. And ordinal data, suppose you have some ordinal data, right? Let's take example of sort sizes, right? Then order must be preserved. In that scenario, bar chart is used, and order must be preserved means, suppose you have small, right? This is some 10 sorts, and medium is 5 sorts, and then large is you have 20 sorts, and let's say 14 of extra large sorts. Then see here, order is preserved. Order is preserved means small is first, then medium, then large, then XL. Okay. In such scenario, first small should be there, then medium, then large, then XL. Okay. Is that okay? You got
it, sir.
Got it, sir. Got it.
You can sort the frequency, you can plot the Pareto, but best practice will be you have to must preserve the order of the data. Is that okay?
Yes.
Yes, sir.
Now come to the
Yes, sir.
sorry. It can be both. It can see first you can plot the Excel for large, for medium, for small, but order should be there if it's ordinal data. Okay. Now come to the area principle. I mean error in graphs, truncated graphs, and all. Okay. Suppose suppose my baseline is not started from 0, started from 5, 10, 11. Okay. And bar charts is some bar charts, some bars are there. Then if it's not started from 0, then there is missing baseline. Okay. Is that okay?
Yes,
sir.
Now,
Okay, sir.
if suppose there is something 0, 5, and 10, sudden is come to the 35, then 45, then 55. Then this is the manipulated y-axis. because my y-axis is manipulated because initially it was 0 to 5, 5 to 10. Suddenly it's jumped to the 35.
Interval
Right?
is not same. No?
Yeah, interval is not same. See, there is some manipulation in your y-axis. Here, there is some manipulation which is not in the which is not in my chart. Okay. Now, one more thing. Suppose this is something bar chart. Let's come to the pie chart. Yeah, who is this? Sadiq, please. Everyone is making some. Okay, see. Pie chart. In pie chart, there is a error. Error is something. If percentage of slices of all the pie, okay, is not 100%, then this is what?
Round off error.
Round off
Error.
Okay. Now you got the missing something and all things.
Yes, sir.
Yes.
Now come to the
Now,
mod and median of a categorical data. Okay. So see, mod is what? Which occur more frequently, right? Suppose I have data of, see, this is something A, B, C, D, C, A. Okay. Then what is the mod of the data?
A.
Okay. And suppose, and what is the median of the data?
CD.
See, this is something data which this is, suppose this is nominal data. Then we cannot calculate the median for this data, right?
Sorry.
Okay. Median you can calculate only for the ordinal data, but mod you can calculate for the nominal data as well as for the ordinal data. Suppose that let's take the example of the search size. Let's take small, large, XL, large, and small. Then what is the mod of this data? Small. What will be the median of this data?
SL होगा.
No. See, for median, first you have to arrange the data in increasing or ascending or descending order. Then let's take the middlemost observation. So middlemost observation is
Large.
No. I think there is 6 observation. Okay.
Yes.
Small and large.
Average
small
of
or
SL,
large
sir.
it will be there. Okay. S or L will be there. Suppose let's take there is one more S. Then
Now yes, sir.
Then
S will be the median, right?
Yes, sir. Got it.
And if there is 2 mod, then your data will be bimodal. If it's single mod,
Bimodal.
then it will be
Unimodal.
unimodal data. Is that clear for everyone?
Yes, sir.
Yes, sir.
Anyone will wants to tell when we have to use the pie chart?
Where share and
When you want to
percentage.
represent a share.
Share. And when to use bar chart?
When there is a counting
Where
of
is a counting.
Counting. Okay. Okay, we can take doubts for up to 5 to 5 to 6 minutes. If you have doubt from week 1 and week 2, otherwise we can move for the week 3.
Yes, sir. One doubt.
Move.
Yeah. Yes, please ask.
Small doubt, sir.
Yeah.
Sir, age would be a ratio or ordinal.
Okay.
Age
Suppose
would be ratio.
How it would be ratio that how we can see a person is age of 0, no absolute 0.
No.
Yeah,
See. If you are saying 0 age, okay, 0 years, that means doesn't there is that means absence of that thing. Okay. See, one major basic difference you can say or tricks between interval and ratio. If it's take the values in negative, then it will be interval. Otherwise, it will be the ratio. That's it. Suppose your age is 40 years, for example, and my age is 20 years. Okay. Then you can say your age is 2 times than me.
Yes, sir.
yes, sir.
Then it will be ratio.
but sir, absolute 0, are we considering that 0 year?
No. See, suppose absolute 0 means what? And absolute 0 means absence of that thing.
Absence of
Suppose
zero,
I'm
yes,
saying
sir.
0 kilo weight of a person is 0 kilogram. Means that person does not exist.
Yeah, right.
Right. And one more important thing you can say, if it goes in negative, then it will be interval. That's it.
Yeah.
Can you say -1 year,
No,
-2
sir.
year? No, you can't say, right? And you can make a ratio comparison, right? For example, here, suppose this is something 0, this is 20 years, and this is 40 years. Then you can say, suppose this is your year, this is someone else's year. Then you can say like my age is 2 times than you. You can say, right?
Yes,
Then
sir.
you can make some ratio. Okay. Is
Okay,
that clear
fine.
for everyone?
Yes, sir, fine.
Okay. Let me create a new Jamboard. So we
Sir,
will start
I have a small doubt, sir.
Yeah. Yes. Please. Please.
Yeah, actually in mode, actually it is the highest frequency, right, sir?
Yes. Yes.
Yeah, but in the graded assignment last time what we had, there was one problem which was saying like some language is the highest mode. So we considered it as the next value of the highest mode, 27, and it was taken as 28 as the mode. So can you please clarify that, sir? Because can the highest number be the mod if there is no mod?
I think that was something asking about highest number relative frequency something, right?
Yes, sir, exactly. It was connected with relative frequency, and it was said.
If I remember, question was like if mod is coming out to be right maximum possible, it was something 45, and it was 27 plus. Can say let's what will be 18, right?
Not exactly. That is not the question, sir. That was saying. The question was something with regards to the languages, Sanskrit and Hindi, English and all. There, it was for the first question. It was being considered as like highest mod. Hindi was the highest mod.
Okay.
So we took that as the next value of the highest number that is available. Actually.
No. See, it depends. See, first of all, you have to take. Can you put the question or whole question on chat or?
Just try to open
okay,
it. Okay,
just search that and put on tell me. We will discuss. Okay.
Yeah, sure. You can go ahead. You can go ahead.
Yeah.
Just find it.
Okay, let's move for the week 3. Actually, we have covered the discrete data and continuous data in week 1, but discrete data and continuous data is in week 3. Okay, you got the concept of discrete data and continuous data. Now we will cover the lower class limit, upper class limit. See, suppose this is your histogram something. Okay.
So one doubt, sir.
Yeah.
Sir, will we have Google Sheets calculations in our exams?
No. You will have only TCS calculator, and your in exam calculation will be such that you can perform the calculation on TCS. I mean okay, that's on that side.
Sir. Will we have any questions regarding Google Sheets, sir?
No.
Okay, sir. Thank you, sir.
Okay. So what are the lower class limit? Just a smallest value of the class, upper class limit, largest value of the class. Suppose I'm saying you have to calculate the class mark. Okay. Suppose this is the class. So how you can calculate the class mark? This is this is nothing but the average of these two. That's it. Okay.
Yes.
And histogram is something which is a graphical summary for your continuous data, and bar chart is for discrete data. Okay, because in continuous is taking some interval, right? It can take any values between the interval. So this is something A, B, B, C, C, D, something and so on. Okay.
Yes.
Okay. Now let's come to the measure of something you can say central tendency and all. Okay. Now you know about mean, right? You can easily calculate the average of a data, right? What is that? Sum of the observation divided by number of the observation, right? Suppose in that data. Yeah, yes, please.
Sir, I have confused what is about the difference mean and the median.
Okay, we'll discuss mean and median.
Median means mid value. Mean means average. Is it, sir?
Median means?
Median means mid value.
Yes.
Mean means average.
Yeah.
It's most of confusing, sir, sometimes.
No, not confusing. See, mean is something. See, measure of central tendency. Central tendency means it gives you a center point, center value of your data. See, mean is central tendency, mode is central tendency, and median is central tendency, right? Now you can calculate the mean as sum of observation divided by total number of observation, right? If in your data frequency is there, then how can you calculate the mean? Summation of fi into xi divided by summation of fi, right?
Yeah.
And you know summation of fi is same as the number of observations. Now, suppose you have old data and new data. New data means suppose you have a data of x size, right? And mean of this data is x bar, okay? And suppose I'm saying you have to add a constant to the all observation of the previous data, and then how will affect the new mean? What will be the new mean? New mean will be old mean plus that
constant.
Okay. Should I derive from here, or is that okay?
Yes.
Can you repeat, sir?
Sorry.
Can you repeat, sir?
Yeah, I'm saying. Yeah. Suppose you have data of x size, okay, and I said for this x size data, your mean is x bar, right?
Yeah.
Again, I said you have to add a constant to all the observations of this x size. Means you have to add constant c, x1 plus c, x2 plus c, x3 plus c, x4 plus c, and so on, xn plus c. Then what will be the new mean? New mean of the data. The new mean will be your old mean, just old mean, and just add the constant. That's it.
Yes,
is that okay?
Yes, sir. Sir, what is this phenomenon, sir?
Sorry?
Property.
Hello?
The name of this, sir.
Name of this something, this not, there is not a some standard name. Suppose see your data 1, 2, 3, okay, then what will be the mean of this data? 2.
Yes,
okay,
sir. Yes, sir.
yeah, mean of, yeah, yeah. One request, please mute all yourself. When you have doubt, then you can unmute and ask or raise hand. Okay, see, mean of this data is 2. Suppose I am interested to add 2 a constant, let's say 4, to all the observation. Then what will be this observation? New observation 5. It will be 6. It will be 7, right? Then what will be the new mean of this data? 6. Okay.
6.
So what is this? Your new mean is equal to your old mean plus that constant.
Yes, sir.
Okay. So see, this is for the sum. This is for the small data. Suppose you have data of 100, and you know mean of the that 100 observation. Then you have to add the constant. Then you have to add the constant to all the observation. Then again you have to calculate the mean. So this is the property for the mean. If you add if you have xi observations and mean of that observation x bar, and you have to add the constant to all the observation as c, then new mean will be x bar plus c. That's it. Okay, direct
Sir,
you can compute, and if you have to multiply that constant, then your new mean will be x bar into that constant. Okay.
सर अगर हमें पर्टिकुलर डेटा पॉइंट में कांस्टेंट ऐड करना हो तो
then your mean will be changed separately. And this does not make any sense. Yeah, you have to select a particular data and you are adding. This is some biasness will be there. Okay, is that clear for everyone?
Yes. Yes, sir.
And you know mean is affected by outliers.
Yes, sir.
Yes, sir.
Affected by outliers means suppose you have data of 1, 2, 3, 4, and 5. Okay, what will be the mean of this data? 5, 4, 9, 3, 12, 2, 14, 15, 3, right? 3. Suppose, and what, suppose this is the mean, and this is, suppose suddenly I add 100. Okay, then what will be the median? Let's take 105. Okay, then it will be 120 divided by 6, right?
Yes, sir.
Then it will be
20.
If you see your mean suddenly changed, I mean,
yes, sir.
is
Yes,
affected
sir.
by the outliers. Okay,
yes, sir.
so mean is affected by the outliers in your data. Is that clear?
Yes, sir.
Now
Yes.
come to the median. Median is what? If your data, see, first for calculating the median, you have to arrange your data in ascending or descending order. Okay, now, and you can take like you can say, first take your n. If it's odd, right, then what will be your median? Median will be n plus 1 by 2th observation, right?
Yes, sir.
And if your n is even, then what will be the median?
n by 2, comma n plus 1 by 2.
Sorry? It's a nothing but mean of the n by 2 and n by 2 plus 1th observation.
2 plus
right?
1 observation.
Okay, is that clear?
Yes.
Yes.
And see, median is no, you can say median is something. Let's take first. See, if you have data, old data, and median for the data is suppose let's take MD. Okay, and I'm interested to add a constant to all the observation. Then what will be new median? Your old median plus that constant. Okay, and suppose I have to multiply it by a constant. Then what will be the new median? My old median into that constant. Okay, let's take example of this one. 1 2 3 4 5. Okay, if you take 1 2 3 4 and 5, if you add a one constant like 1, then it will be 2 3 4 5 and 6. Okay, what is the median for this data? 3. What is median for this data is
4.
See, this data is already in ascending order, but first you have to arrange in ascending order. Then can I say my new median is equal to old median plus constant, right?
Yes.
Similarly, if I have to multiply it by 2, then what will be? It will be 2, it will be 4,
Old median plus
it will
into
be 8,
constant.
it will be 10. Then median of this data is 6, right? What
Yes.
is this? This is old median into 2, because old median is 3.
Yes, sir.
Is that clear for everyone?
Yes, sir.
Now come to the concept, right? Like median is not affected by, you can say least affected by outlier. Suppose this is data. What is the median of this data? Is 3.
3.
And suppose you add outlier 105. What is the median of this data?
7. 7.
7 by 2, that is 3.5.
3.5.
Okay, this is least affected, not much affected like mean, because if you see in mean is changed 3 by 2 20, right?
Yes, sir.
So is that clear?
Yes, sir.
Now come to the mod. What is mod? Mod is, which occurs more frequently, right? So similarly for the mod, suppose your data is 1 2 3 4 4 and 5. What is mod of this data?
4.
Suppose I have add a constant. There is some background noise. Yoga, can you please mute yourself? Yeah, thank you. Suppose I'm adding a constant 1. It will be 2. It will be 3. It will be 4. It will be 5. 5 and 6. What will be mod of the data set? 5. What is
Old
this?
mode
This
plus
is old mode plus that constant. Constant is 1. Similarly, if I have to multiply it, then my new mode will be old mod into C. Okay, is that clear for? Similarly, mod is least affected by the outlier. Suppose I have added 105. Okay, then mod is still same, right?
Yes.
So it's least affected by the outlier. Till this point, it's clear. Mean, median, mod, adding constant, multiplying constant for mean, median, and mod, everything. Then we will move for the measure of dispersion. Okay.
Sir, can you show the last slide once, sir?
Yeah. Yes, please. This one.
Yes, sir. 1 minute, sir.
Yeah, please.
Sir, meantime, Josh
median
was...
you added 105 now, sir. No,
Sorry?
please explain that part only.
This part? Yeah, this part is for particular outlier. Suppose I have add a outlier, then mod is still is 4, right?
It's not affected, sir.
No, you can say it's least affected. See, it's particular data. It's for particular data. It's not affected, but it is least affected by the outliers. Okay.
Okay.
Suppose outliers is already 3 times, and your 4 is 2 times. Okay. Then it's I mean it depends. It's least affected by the outliers. Okay.
Okay.
Now,
Sir.
oh, someone says to okay.
Yes, sir.
Can I move?
I have noted, sir.
Okay. Okay.
But one doubt, sir.
Yeah. Yes. Please ask.
Sir, how old median plus the new one, that is the new mode equal to not that thing, sir. New mode equal to old mode into C. Can you explain me that concept only?
Okay. Suppose this is your old mode data up to 5, right? Suppose I have multiplied by the 2 for all the observation, then it will be 2, it will be 4, it will be 6, it will be 8 and 10, right? What
Yes,
will
sir,
be the...
I could get that, sir.
What will the mod of this data is 8,
8.
and mod of old data is 4.
Yes,
So
sir.
see, instead of multiplying to all the constant by that, all the observation by that constant and then took the mod, if you know the property, then you can directly calculate the new mod.
Sir, similarly, the median.
Yeah, similarly for median, similarly for mean.
Okay, sir.
Okay. Now come to the range. Okay, just come to the range. Range is what? Range is nothing but the maximum minus minimum of the data. Okay. Suppose your data 1, 2, 3, and 4, 5. Then what will be the range of this data?
5 minus 1.
5 minus 1, that is 4. Okay. So range is something. See, range, variance, standard deviation, quartiles, these are type of things comes under the measure of dispersion. Okay. Now, see, and range is least is sensitive to your outliers. Means sensitive. Suppose this is your data. Initially, your range was 4. Suppose I have added outlier, let's say 205. Then what is the range of this data? 204.
Yes, sir.
Okay, so it's suddenly it's very sensitive to the outliers. Okay.
Yeah.
Got it.
That is it.
Now come to the variance. See, variance is, we have two variance of two things. Means variance for population and sample variance. So population variance is what? Is nothing but 1 by total number of observation summation I is equal to up to n xi minus x bar square. It can be represented sigma square, and sample variance is represented as small s square, which is n minus 1 summation I is equal to 1 to n xi minus x bar square. Okay, you can take as n, small n is here also. See, this is nothing but about the total number of observation, and in sample it is divided by n minus 1. Okay. Okay. See, what is concept behind dividing n minus 1? This is not in this your foundational course. Okay, you will.
So xi minus x bar is only the deviation of that data, no sir?
Deviation of the data from mean.
Okay, sir.
Okay. Now, suppose I have to add a constant to the variance. Then what will be the your new variance?
Variance becomes constant.
Nothing change.
Same as old variance. No change.
Yes, variance will be, new variance will be same as the old variance, because I am taking I'm doing, suppose my new data will be y is equal to xi plus c. Okay. If this one, then can I write y bar equal to x bar plus c? Can I write? Now, suppose my variance is this xi minus x bar square. Okay, 1 upon n summation. My xi will be changed out to be yi, right? That means I have to add a constant to all observation minus. In x bar, my constant will be added, right? It will be 1 by n. It will be xi plus c minus x bar minus c whole square. My c will be cancelled out. So 1 upon n xi minus x bar square. Initially it's yi minus y bar. So my new variance is same as the old variance, because my constant will got the cancelled out.
Yes. Yes, sir.
Okay. Got, when we have add a constant, then my new variance will be equal to the old variance. Okay. Now, suppose I have to multiply by a constant, then what will be my new variance?
The squared of the constant into the variance.
Yes. New variance will be squared of the constant into old variance. Because if in this formula, if you see, in this formula, it will be xi times c, right? Minus x bar times c. Your c, if you take as a comma, it will come out to as a c square. Okay. So it will be c square something, this formula.
Got it.
Got it? Is that clear for everyone?
Yes, sir.
Yes, sir.
Okay. Now come to the standard deviation. So standard deviation is what? It is just nothing but the square root of the variance. Okay. if you set sample by a sample standard deviation, it will be 1 upon n minus 1 summation xi minus x bar square, and population standard deviation, it will be 1 upon n summation xi minus x bar square. See, suppose I have to add a constant to all the observation, then what will be the new standard deviation?
Nothing change.
Nothing changed.
Nothing change. And multiplied by a constant, the new standard deviation?
That's
Three
the
times.
constant into the variance, root under variance.
No, constant into the old standard deviation.
Yes, sir.
See, just constant. Why constant? Because we are taking the
Root under
square
the
root.
c square, that is c.
Yes. Okay. And see, your variance and standard deviation is affected by outliers, right? Okay.
Sir, repeat.
I'm saying standard deviation and variance is affected by the outliers, because if you see
Okay,
in the
got it.
formula xi minus x bar, so it will affected by, because see, mean is affected by outliers. Okay. And in variance
sir.
formula, we are taking the deviation from mean, then automatically it will be affected by the outliers. Okay.
सर वो expanding formula सर variance का.
Which one?
सर वो जो expand करके formula आता है variance.
Okay. I will tell. Yeah. Suppose this is one. I'm taking this. Okay. Okay. Now 1 upon n summation. Can I say like xi square plus x bar square minus 2 xi into x bar? Nothing but the expansion of a minus b square, right?
Yes.
Now just take the summation inside the bracket. It will be summation xi square plus summation x bar square, okay, minus 2 times x bar summation of xi, right? Because summation is for the I, okay, and x bar is a something constant. Okay, you know x bar is what? 1 upon n summation of xi, right? So can I write summation of xi is as a n times of x bar?
Yes, sir.
Is that okay for everyone? No. Summation of xi square, okay. See, this can I write n times of x bar square, because x bar is constant and I have to just add up to n times, right? Now, minus 2 times of x bar, can I write summation xi as a nx bar?
Yes, sir.
Okay. So it will be 1 upon n summation of xi square plus n times x bar square minus 2 n times x bar square. Okay. Again, I can write 1 upon n summation of xi square minus n times of x bar square. Okay. Is that okay for everyone? Got it?
Yes.
Yes, sir.
And you can take a screenshot of these things, because this is a very important thing.
Okay.
Okay.
1 second.
Yeah. This is the important. Just if you remember this formula, then you can solve the questions easily.
Sir, one more doubt.
Yeah.
सर ये फॉर्मूला यूजुअली उसमें यूज होता है उस टाइप के क्वेश्चन जिसमें आपका एक डेटा पॉइंट गलत होता है. तो सर जब मैं इस फॉर्मूला को यूज करूंगा तो इसमें एक्स बार और एक्स आई हम रॉन्ग डेटा यूज करेंगे कि करेक्ट डेटा?
No. You have to correct. You have to subtract wrong one and then add the correct observation. Then you have to proceed. Okay.
Sir, can you please explain with the help of an example?
Yeah. So for example, only I'm going to talk.
For that example, you can go through the solution PDF of week 3 graded.
Sir, I have a small doubt, sir. In the qualifier exam, the question was been asked in the way like the mean and the population standard deviation of marks out of 50 scored by a student of 10th class in an aptitude test is 25 and 10 respectively, which means like the standard deviation is 10 earlier. Okay. And the marks, modified marks is 3 times of marks into 5, sorry, plus 5 divided by 5. So how do you find the modified population standard deviation, sir?
Oh, see. Once again, see, there is some.
Let's take this as an example, sir.
Okay, see. Yeah. You know, if you what that 2 times of marks plus 5 divided by 5?
3 times of marks plus 5 divided by 5.
Okay. What was the, you know, if you add a constant in initial observation, then your new variance will equal to the old variance.
So your screen is not visible, sir. If you don't mind, can you please look it in a Google new Jamboard?
Okay, 1 second. Now is my screen visible? Is visible?
No, sir.
Yes,
Yes,
sir. Now
sir.
it's visible. Yeah.
Okay, see,
Yes,
you know,
sir. Now it's visible.
when I have to add a constant, then what my new variance is same as the old variance.
Okay.
Okay, you understood this property?
Could
And
you, if you don't mind, can you please do with this example, sir, so that everyone could be able to understand?
yeah, I will explain. See
Yeah,
what
sure,
I'm
sir. I'm sorry.
why yeah. See, if you multiply by a constant, then it will be square of the old variance. Okay, you know this property. Okay, you are saying 3 times of marks plus 5 divided by 5, right?
Yes, sir. Right.
And what are the standard deviation for the marks?
The old SD is 10. You wanted to find
10,
the new
right?
SD. Yeah.
Okay, suppose let's take this one initially. Okay, suppose, okay, if you multiplied by a constant, see, suppose you know this is your xi. If you multiplied by a constant c, then what will be new standard deviation is equal to c times of old standard deviation, right?
Correct,
So
sir.
your
Right.
old standard deviation was 10. There is not effect of addition any constant, right?
Okay. Correct, sir.
Okay, and here there is a multiplication of 1 by 5 also, right?
Yes, sir. Right.
So it will be 6. That's it.
No, but the answer is 2, sir.
Answer is 2.
Yeah.
Then it will be something different. I mean, marks will be some different.
No, sir. It is just the same. That is where I got
No,
confused, sir.
no. It will be different. If answer is 2, then it will be different. Please check that one.
No, the question is very clear, sir. The population standard deviation of 50 students, okay, in an aptitude test is 10.
Okay. What is modified marks?
Modified marks is 3 times of marks plus 5 divided by 5.
Divided by 5, right?
Yeah.
3 times marks. Okay, 30. Answer is 2.
Yes, sir. Answer is 2. I'm sorry, sir. I'm very sorry. Answer is 6. You are right, sir. I'm very sorry. You are right.
Okay.
Extremely sorry, sir. I got it, sir. Yes,
Okay.
sir. I'm sorry. I'm sorry.
You got it?
Yeah, I got it, sir.
Who is this? Okay, you got it? Is that clear?
Yes, sir. Very clear. Thank you so much,
Yeah.
sir. I'm sorry.
Now come to the percentile. Okay. Yeah, see, it's already 10. We have to cover. Yeah, percentile. See, percentile is what? Percentile is nothing but, suppose this is your data, right? Suppose I'm saying 50th percentile. So percentile means 50% of the data will lie below this, and remaining 50% of data will be lie above this. Okay. Suppose I'm saying 25 percentile. Okay, that means 25% of the data will be lie below this point, and remaining 75% of the data will be lie to above this point. Is this clear?
Yes, sir.
Now come to the how to compute the percentile. First, you will have some n number of observation. Okay, and you will give a suppose p some percentile. Let's say you have to compute the 30th percentile. So your p will be 0.30, right? And let's take n is as a 10. So first, for computing percentile, first step is you have to arrange the data in ascending order, right? Okay. Now, after that, compute the value of NP. If it's in decimal points, okay, then take the next smallest integer greater than the p, right? NP. Okay. I will come to the. I mean, I will cover by the example. Another example. If it's your NP is in integer, right? Then take the mean of the average of the NPth and NP plus 1th observation in the data. Let's take an example like 1, 2, 3, 4, 5, 6. Let's take it's 11. Let's take 10, 2, 12, Okay, let's say 7, 13, and 15. Okay, so now first you have to arrange the data in ascending order, right? First step, what will be 7, 10, 12, 13, and 15, right? Here my n is what? 5. Let's say you have to compute the 30th percentile. So P will be 0.30, right? Now my value of NP will be what? 5 into 0.30, what will be this? 1.5, right? Hello?
Yes, sir. Yes, sir.
Yes, sir.
Yeah, it's right. So see, value of NP is in decimal, so we have to take the next smallest integer. So we have to consider the second observation, that is 10. So my 30th percentile of the data will be 10. Is that clear?
Yes,
Now,
sir.
suppose
Sir.
your n is 5 and you have to compute the 20th percentile, right? So your P will be 0.20, right? So value of NP will be what? 5 into 0.20, that means 1. See, this is in integer. You have to take the average of the first observation and the second observation, that means 7 plus 10 by 2, that will be 17 by 2, that will be 8.5. So 8.5 is the 20th percentile of the data. Is that clear for everyone? Why I took the next integer and why I took the average of the data?
Sir, can
Is
you
that
repeat
clear?
the first one, sir? Like
This one?
no, sir. When n equals to 5, no, sir, P equals to 0.2, sir. 20th percentile.
Okay. Okay. See.
Hello, sir.
Yeah.
So what is NP? Number of percentile?
No. See, n is your number of observation. Here my number of observations is 1, 2, 3, 4, and 5, right?
Yes, sir.
And P is percentile. What percentile you have to calculate?
Yes, sir.
Okay. So for the percentile, first you have to arrange your data in ascending order. Then you have to calculate the value of NP. If its value of NP is in decimal, okay, then you have to consider the next highest integer, next smallest integer. So this is 1.5. So next smallest integer will be what? 2. So you have to consider the second observation. So 10 is the second. Yeah.
Sir, when it is 1.2, then also it is treated as 2.
Yeah, because for 1.1, 1.9, 1.5, is next smaller integer will be what? 2. That's it. Okay.
One doubt, sir. Sir,
Yeah.
how did you calculate P equal to 0.30, sir?
I just assume, I suppose I have to calculate the 30th percentile. That's it.
Okay, sir.
Okay. So I have to take the second observation. Now in this particular example, if you see our P is 0.20, I mean, say suppose you have to calculate the 20th percentile, then value of NP will be 5 into 0.20. 5 into 0.20 will be 1, right? Now if it's 1, then it's in integer. If value of NP is in integer, then I have to take the average of NPth observation and NP plus 1th observation. That means average of 7 and 10. This is 1. The average of you have to take first and second observation. That means 7 plus 10 divided by 2. That means 8.5. Is that clear for everyone?
Sir, now if we assume we got NP equals to 3, sir, then we should do 3 plus 4
3
by 2.
plus
So like
4.
12 plus 13 by 2.
By 2. Yeah.
Okay.
We have a complete value, then we'll add two values to the average, sir. We have an incomplete value, then move to the next value, sir.
Next
one is like 1.5. We go to the second value.
Yeah. See, if it's in decimal, then you have to consider second. See, it's 1.5, then we have to consider second. That means 10.
Okay, sir.
Okay. Okay. If it's suppose 2.5, then you have to consider the third observation. That means 12. Is that clear?
Yes, sir.
Okay. 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 See, and you know percentile.
Again, repeat, sir.
Yeah, sorry.
Repeat, sir.
Which one?
Yes, sir. Yes, sir. 7 plus 10 by 2.
Yeah. See, you are not listening to me carefully. See, please. If your value of NP is in integer, value of NP is what? 5 into 0.20 is 1. Okay. 1 is as an integer. So you have to take who is this man? Please don't do this if you doubt. Otherwise, unmute yourself. Otherwise, mute yourself. Okay. Yeah. See, if your value of NP is in decimal, like 1.5, then you have to take the
Next integer.
Next integer. And if your value of NP is in integer, then you have to take the average of the NPth and NP plus 1th observation. Like your value of NP is 1, right? Then you have to take the average of first observation and the second observation. Okay. You know, yeah. Now percentile is what? Suppose this is something minimum value of the data. This is something maximum value of the data. And suppose there is 30th percentile. Okay. This is no. Let's take a 50th percentile. This is something 30th percentile. Okay. Suppose I'm saying 30th percentile at the 30th percentile there is value 28, and at the 50th percentile there is value 30, right? So can I say between these and this value can be 28, 28, 28, 28 also, right?
No, 28, 28 point something.
I can say, and between, see, because 30th is 28, 50th is 30, then it can be 28 from this to this point. It can be 28, it can be 28, 29 also, and it can be 30, whatever it will be, but it will be only between the from this value to this value. Okay.
Okay.
Yes, sir. Sir, sorry to interrupt, sir. Your battery is discharging. Like.
Okay. Thanks for reminding. Once you let me connect for the charger. Now come to the quartiles.
Excuse me, sir. I have one doubt.
Yeah.
Generally, we have a 0.1 is a 10th percentile consider, but 0.09 is a 9th percentile, sir.
Sorry.
0.09.
See, I'm saying you have to calculate the 90th percentile. That means your P will be 0.90.
Okay. Suppose we calculate the 90% means
0.09. Yeah.
0.
Okay. Quartiles. Quartiles means something quarter. Quarter means 1/4, right? Suppose this is your something whole data. Okay. This is the minimum value of the data. This is the maximum value of the data. And this is the 50th percentile of data. Okay. So quartile is something. This is Q1. This is Q2.
Sir.
Yeah. So quartile is something which divided your data in 4 equal parts. That means this is covering the 25% of data. This is cover the 25%, 25%, 25%. Okay. Now Q1 is what? Q1 is what? 25% of the data, right?
Yes.
Q2 is what? 50% of the data, right?
Sir.
That means,
sir.
Yeah.
I'm kind of confused on what you just said though.
Which for what?
Yeah.
For what? For quartiles.
Yeah.
Yeah. See, quartiles is something which divides our data in 4 equal parts, right? Quartiles. Yeah. Suppose my data is from here to here. Okay. So my quartile is Q1, Q2, and Q3. So it's divided our data in 4 equal parts, right? So first parts will cover 25%, second part will cover 25%, third part will cover 25%, and fourth part will also cover the 25%, right? Similarly, I can say my first quartile, which represent at the Q1, is cover the 25% of data. Q2 covers the 50% of data, which is same as the median, because median is the middle observation, and Q3 is the 75th percentile of the data. So this is not percent, this is percentile. So you got the concept, Q1, Q2, Q3, right? You know about the 5 number summary. Okay, now is that clear for everyone? See, Q1 is what? 25 percentile of the 25th percentile of the data, right? Now, suppose I'm saying that you have to calculate the Q1, then you have to arrange the data in ascending order first, then you have to calculate the N, and what will be P? P will be 0.25, right? What will be, how you can calculate the Q3? P will be your 0.75 and N, then calculate the NP and proceed further, right? Similarly, I can calculate the IQR. IQR is nothing but the Q3 minus Q1. Is this clear for everyone? Suppose I'm asking calculate the IQR,
yes, sir.
Then you have to calculate the Q1, you have to calculate the Q3 and subtract the Q3 minus Q1. right?
Yes, sir.
You know what are outliers? How you can calculate about outliers? Outlier is something nothing but is less than Q1 minus 1.5 times of IQR, and if it's greater than Q3 plus 1.5 times of IQR, then that observation or data will be considered as a outlier. Is this clear for everyone? Means your data, then calculate the Q1, calculate the IQR, I mean apply this formula, and if there is any observation which is less than this value, that will be considered as outliers, or if there is any observation which are greater than this value, that will be considered as an outlier. Is that clear for everyone?
Yes, sir.
And one more thing which we have missed in this week 3, that are stem and leaf plot.
Sir,
Okay.
repeat again, sir.
Which one? This one? This outlier formula?
Yes, sir.
Yeah, see, suppose I'm question is you have to find the how many outliers or what is the outliers in your data. Then first you have to calculate the value of these things, Q1 minus 1.5 times of IQR. Okay. Then suppose this value is come out to be 10, for example, let's take. Okay. And this value is come out to be, let's take 105, for example, just assume. And there is observation in your data which is minus 2. And is there any observation which is an observation in your data which is, let's take 923. So this minus 2 is less than this 10. Okay, that will be outlier. This observation is greater than this 105. That means this value, that will be considered as outlier. Okay.
So can you give a brief explanation of interquartile range?
Yeah, IQR is just nothing but Q3 minus Q1.
Okay, fine. So for data, there can be two outliers.
Data can be?
Like a data can have two outliers.
Yeah, data can outliers. Okay. If you're asking about find the outliers, then just calculate this value, Q1 minus 1.5 times of IQR. And if there is any value which is less than this value, then that will be considered as outlier. If there is any value which are greater than this after calculating the value, that will be considered. And you can calculate the IQR as Q1. Q1 is nothing but the 25th percentile of the data. Suppose you have data, you have to arrange the data in ascending order, then calculate the N, and P will be your 0.25.